Okay, so we are going to spin up, before starting we're going to spin up a small Slido quiz. So if you can go to slido.com and enter the code and the passcode, or you can just scan it from your phones. And we wanted to ask you, what all have you learned so far in this winter school? So any keywords, if you've learned cryptography, put in cryptography. Whatever you've learned, we want to see what all you've already learned.
This event
Yeah,
code.
event code is the number 3978163 and the passcode is MXBTCW. So we'll be using the Slido quiz a couple of times more during the session also. So keep it logged in, keep it open. Let's not disturb the setup. So cryptography. So you can enter it here. Send. Okay, cybersecurity, malware analysis, cryptography, cryptanalysis, okay, asymmetric, symmetric encryption, perfect secret. Is everybody able to log into Slido? Any issues so far? No, right? All right, then let's look at the results. So another quick poll, raise of hands. All of you have Kali Linux installed. I can see Kali on this. All right. Okay, perfect. Network tapping, dark webs, cyber kill chain, traffic analysis.
So it's still writing. Everyone done?
CTF. Anybody wants to say what they learnt about CTFs?
But who wrote CTF?
Has anybody participated in any CTFs until now? You have? Okay. So let's start off. And while we start off, let's talk cybersecurity. This is something that went around in our circles during the lockdown, that for cybersecurity professionals, there is no time to rest. Whether COVID happens, whether a hurricane happens, anything happens, hackers are always there. Risks are always there. So wherever there is a risk, we need security. And the core concept of cybersecurity is that prevention is better than cure. That is also the core concept of medical science, but it's also the concept of cybersecurity. So let's spin up a small scenario. So you guys are students, you are here in VIT, you are attending the ACM winter school, right? And you are connected here with your personal devices, with your laptops. So how do you think that your laptop is going to connect to the VIT network? So see, we want this session to be interactive. We want you all to speak up. And we realize that you might not know the answers because we are asking you questions preemptively. So feel free to throw out answers. They can be wrong. There's not a problem in that. And we will obviously tell you what the right answer is and how things are done. So right now I'm asking you, what do you think from your laptop? What is the first step to connect to the VIT network? Anybody? Where is the pen? Spin up the PC. Okay, this is horrible. So you have your laptops. I'm sorry, this pen is making it horrible. So what is the next step? Are you connected to Wi-Fi? It's as simple as that. You say that you are wirelessly connected to Wi-Fi, right? So then there is an access point. And if some of you were connected via Ethernet, then there would have been a switch somewhere, right? So there can be an access point, there can be a switch. So wirelessly or wired, somehow you are connected to the network. Now, after the first device, there might be a router, right? A router that can connect you to VIT's network. So we can have a router here. And then ahead of that router, we might have an entire VIT's network where We have internal VIT resources, external resources. We can have some databases, some faculty repository, some student repository, right? And then finally, from this internal network, we might be connected to the internet. Okay, this pen is not working properly. Okay, let's just assume that this is the internet. Okay, all right. So, that big empty box, what do you think goes on in there? I already told you that databases, repository, and all of that might go in there. But let's talk in terms of security. So, what do you think are the security devices or the security concepts that might apply in this big empty box or even in the rest of the network to make sure that VIT, this as an organization, is safe and secure? So, we've launched. Okay, so we have launched another Slido poll, and we want to know what you think. You can either raise your hand and speak up, or you can put in your answer in the poll. What do you think goes in that empty box? What do you think are the places where security concepts come in?
We have a couple of people.
Okay, we have some answers already. Firewall, wonderful. IDS, IPS. A quick question, once you submit, are you able to see the word cloud with the others' answers also, right? Okay, then we are not going to project that. Okay, so we have firewall, IDS, IPS, passwords, perfect. Data-centric security, networks, edge. So a lot of you think that a firewall is supposed to be here, right? So somewhere, maybe after the router, we have a firewall. Okay, some of you said passwords. So when you say password, that means that each of you has a unique username and password, is it? So then those usernames and passwords also need to be managed or stored somewhere, right? Yeah. So some device or some repository, something should be there to handle all of these things. So something to handle passwords is also going to be there. Then some databases are also going to be there. We are going to chalk up all this bad drawing to the pen. And okay, I think we have a good number of answers. Authentication.
ACLs, antivirus,
Yeah.
authentication has been an answer.
Okay. Can we do the same diagram on the board as well, just for clarity? Is that okay? Right. That's better. This is AP. So this is the switch, AP, your PCs, and then we have a router. Let's call it R1. Then we have this huge VIT box. And then we have the internet. And now you said firewall. So let's put a firewall here. And then we have some databases. And we have one AD, DB, DB. Okay. Some else of the architecture also would go here. And let's keep it at that right now. So in this session, we will begin with the basic concepts of what goes into securing a network. Once again. All right, so a lot of you put in the answers as IDS and IPS. So what is the difference between an IDS and IPS? IDS is just a detection system, right? What we are saying is that traffic is going through, it is analyzing that traffic, and it is telling you whether there is a possibility of something malicious going on in there. So it has its signatures, its databases, everything, and it will make the analysis, and it might send you an alert to say that, please check a particular resource, there might be something wrong going on over here. IPS on the other hand is an active thing. So it will determine that something is wrong and it will block it right there. So it's a basic difference between IDS and IPS. I'm not going through the text over here. I'm sure you all are aware. But this is the basic difference between an IDS and an IPS. So what do you think when we talk about a firewall? Are we referring to an IDS or an IPS? IPS, right? Absolutely. So what do you think is an IDS? I mean, where do you apply an IDS in your daily life? So your laptops have antivirus, right? That is an IDS. Because if you download something from the internet and it cannot verify the signature or it determines that it's a malicious file, it will give you an alert and say that, please look at this file. You need to quarantine it. Something might be wrong here. So that is an example of a host-based IDS. And your firewall is generally an IPS. So again, let's talk about security zones and levels. So we have a firewall, we have a corporate network. Let us assume this is the VIT network, not a corporate network for the purposes of our explanation, right? And we have the internet and we have something called the DMZ. The DMZ stands for demilitarized zone. So it is an intermediate network between the inside and the outside, your secure and your unsecure internet. It's something in between, and it hosts services that are accessible internally as well as externally. So most organizations have these three major zones: inside, which is secure; outside, which is external, which is the rest of the world, rest of the internet; and the DMZ, which is the intermediary. So we talk about security zones. So when we talk about firewalls in general, we work in Cisco and we have Cisco firewalls. So Cisco firewalls have three zones. Other firewalls also have, but let's talk in terms of Cisco. So we have three zones: inside, outside, DMZ, and by default, when we create an interface, so we can see that the firewall is connected in three interfaces. So the inside interface by default will have a security level of 100, which is the highest security level, and the outside interface will have 0. And then anything in between, the DMZ can have anything between 1 to 99, it can have anything. So why this security level? Why this concept of security level? So by default, a firewall allows traffic from a higher security level to a lower security level. That is a basic concept in a firewall. So far so good? So for example, if you are user inside VIT, you are a faculty or you are somebody and you want to access some website on the internet. So you can access it because you are at a higher security level. But for example, there is an attacker who is outside VIT, who is somewhere on the internet. He is trying to access an internal resource of VIT. Then by default, the firewall will block it because of the security level difference. All right. So that is the concept of security zones and security level of interfaces on a firewall. All right. So far so good? Any questions? No? Simple enough. So what is a firewall? At its core, firewall has two functions: permit or deny. That's it. So it is an access control device. It will look at whatever traffic, whatever packet is coming its way. It will look at the packet, what is the source IP address, destination IP address, port number, what is the service. Based on all of that, it will make a decision whether it wants to permit a traffic or deny the traffic. And then how does it make that decision? It makes that decision on the basis of access control rules that you as a firewall administrator will apply on the firewall. So a firewall will make this. So again, it's a simple network diagram. You have your inside network, firewall, DMZ network, outside network and the internet, right? Yeah, so this is what I said. By default, firewalls will allow traffic to pass from higher security to lower security. But then there is a problem here, like it says, that if it's a TCP connection, for example, it's a web traffic, right? So you as a user, again, I'll take the same example. A faculty is trying to access a website on the internet. The website is also going to send packets to that person, right? The return traffic will also come. So that return traffic will be allowed in the case of, like, for example, TCP or UDP. Based on an already established session, the return traffic will be allowed, even though the security level condition is not fulfilled. So again, that is a context aware, that is a stateful firewall. For ICMP, this doesn't apply. ICMP is your ping. I hope everybody knows that. Okay. So we can use firewall in three ways, three major ways: packet filtering, proxy server, and stateful packet filtering. Packet filtering is a very basic, very dumb concept based on security level, based on security zone. Each packet permit or deny. That's it. So that is your packet filtering. So you define an ACL, you define your security zones, everything. So packet will be permitted or denied. That's a simple packet filtering. That's a dumb firewall. Then stateful packet filtering. So that is the second thing I mentioned. That in the case of a TCP connection, we are permitting the return traffic. So how are we doing? Because the firewall is aware of the state of the connection. That is why it is allowing that return traffic. So that's why this is called stateful packet filtering. So not only based on the source and destination address, but also on the packet's context, on the already established session. So that is what is stateful packet filtering. So most modern firewalls, actually all modern firewalls follow stateful packet filtering only. So again, this is one example. So for example, somebody from the inside is trying to access a website, some sports website somebody is trying to access. And then the sports page is sending them a reply. So return traffic is allowed. So that is what a stateful firewall is. And then if there is a traffic that is originating from the outside only, and there is no already established session, then it will be denied by default, as usual. So that is stateful packet filtering. And then proxy server is, again, I think it's a concept you are all very familiar with, that a firewall is acting as a proxy server. It will make all the requests, it will receive all the responses on behalf of whatever is there inside the network. So this is also called application gateway. So there are three ways that we can, broad ways in which we can use firewalls. Interfaces and security levels, this also I just explained. So when we configure, a good practice, when we configure any interface in a firewall, we should configure it with a name and an assigned security level, right? So that's what I said, inside has a default security level of 100, outside has 0. DMZ also has default 0, actually any other interface has default 0 and you can set it to something else. All right. So let's talk about Cisco firewalls. So three broad categories here again. We have the Cisco ASA, which is Adaptive Security Appliance. Cisco FTD, which is the Firepower Threat Defense, which is a next-gen firewall. And we have the Cisco iOS firewall. Now, when I say iOS, I'm not referring to your mobile devices. I am referring to the software that is used in Cisco routers or Cisco switches, routers, L3, L2 devices, right? So three kinds of firewalls are there. ASA and FTD I will cover, but let's be done with the iOS firewall first. So iOS firewall is not a separate product in itself. It's just a security feature set in the existing iOS software, in your existing router software. So in this diagram you can see, when we talk about the router R1, at that stage itself, we can apply some security features. So that is a router firewall. So router can act as a stateful firewall, but of course, if you want a more functional, for a bigger deployment, if you want a proper firewall functionality, then of course you should go with a dedicated firewall, something like an ASA or an FTD. So that's how it comes into picture. So let's talk about the ASA. ASA stands for Adaptive Security Appliance. This was one of the, so it started with PICS, but the second firewall Cisco came up with was ASA. Now ASA is also not so much used, mostly we have switched on to FTD. But so ASA performs all functions of the firewall. It acts as a gateway between networks. It enforces access control lists. It is capable of NAT. Are you familiar with the concept of NAT, network access control? Okay, perfect. So again, that's what ASA does, applies policies, does NAT, does traffic control, quality control, a lot of things ASA is capable of. So this is the benefits and features: stateful packet filtering, high-speed NAT, protocol and application inspection. So again, in the access control lists, you can specify them, make them as granular as you want. You can specify a rule for a particular protocol as well. So that is another thing, modular policy. So VPN, ASA is also capable of VPN. Security context, again, we'll cover all of this, high availability clustering. These are all general concepts. So yeah, let's talk about security context. So we'll come back to this diagram here. So you are students, you are guests in VIT for like 10 days and you are accessing the VIT network. Now Ashwani sir is a faculty and there are other faculties here. They are permanent employees of VIT and they are also accessing the VIT internal network. Similarly, there are students also, there are administrators also, there are non-technical, technical staff, there are contract workers. A lot of people are there, right? So, what if you want you all students, your guests to be managed in a separate way, faculty to be managed in a separate way? Like they should have a specific structure for accessing the internal resources. Students should have a specific way. So what if you want to make it all very modular and very separated from each other? So what if you want multiple firewalls that can work independently and manage a huge organization, for example VIT, or for example some big organization like Cisco or any corporate. So it is possible that for multiple rows, for multiple departments, you might want to have multiple firewalls, right? And it is also possible that you only have one hardware box, right? Hardware or a virtual appliance. You have one firewall, whether it's ASA or something. You have one box, you have bought that box and you want to utilize it for multiple departments. So what do? You create virtual firewalls. This concept is called security context. So one firewall can be split into multiple virtual firewalls, which are each of these split firewalls, virtual firewalls, are called security contexts. So this is one way of handling complex scenarios, complex situations. The next concept is high availability or failover. So again, I'll paint you a picture in this scenario only. You have one firewall and you have your entire network there. What happens if this firewall goes down? Something goes wrong with the hardware or some natural disaster happens, something happens and this firewall goes down. What will happen? Everything is connected to this firewall. All traffic is going through this firewall and the firewall itself has gone down. What will happen? Entire network is gone, right? Now, we don't want that to happen. No organization wants that to happen to them. So that's why we bring the concept of high availability. So what high availability stands for is that instead of using one firewall, we'll use two firewalls. Now, there are two ways we can do this. What we can do is, one firewall can be the active firewall, and if something goes wrong, traffic will automatically switch over to the other backup firewall, which in this case is called the standby firewall. That is one way to do it. Now somebody might come and say that, Pooja, I have bought two firewalls, I have paid for two firewalls, and one firewall is sitting idle 90% of the time. So how is this a better utilization of my resources? How am I getting my value for money? So then I can tell them that, okay, you do one thing. You use the active configuration here. So both firewalls will simultaneously process traffic. We can make that division of labor between the two. Now, if one of the firewall goes down, then its traffic will go on to the other firewall, right? So one firewall will start fully processing the traffic, but if nothing is wrong, then both firewalls will simultaneously be running. So that is the concept of active high availability. So this whole concept is called failover. Something fails, we switch over. So this concept is called failover. Any questions? Active, standby, active. No questions? Okay. Then we also have the concept of a transparent firewall. If in case an organization wants to deploy a firewall, but they don't want to make it visible to either users or to external people, they don't want to make it visible. So the firewall will act as an L2, layer 2 hop. It will not have Like it will not change any IP addresses. Nobody will get to know that there is a firewall between them and the internet. So that is the concept of a transparent firewall. We also have the concept of an identity firewall. This is not like, it's not a very popular use case, but we can use a firewall to perform identity functions. We will get into the identity aspect of it in the later slides as well. But anyway, this is also one way of using a firewall. So let's talk about NAT. So a lot of you said that you are familiar with NAT. So can somebody tell me what do you know about NAT? Like, do you know the concept? Or do you know the types of NAT? Or anybody? Yeah, please go ahead. Okay. Anything beyond that? That's it? Anybody knows? So NAT translates private IP into public IP. Anybody else? That is absolutely correct. Anybody else? Okay, so let's get into NAT. So I'm sure you're familiar with the need of NAT. We have a limited set of private addresses. We can see RFC 1918. We have only three of these subnets, and the entire world cannot function like this. So of course the problem was there. And to counter that, we created the concept of NAT. So we can translate these addresses for the purposes of internal subnets communicating with the internet. The concept of network address translation was introduced. And another role of NAT is increasing the security, because if you are translating your address, somebody outside cannot know what your inside topology looks like. Right? They don't know your real IP addresses. They don't know that 1.1 is PC1 and 1.2 is PC2, and that they might be connected to the same switch because of the IP address. So somebody from outside cannot know that. So that is also an additional advantage of using NAT. So before understanding NAT, I will quickly talk about objects and object groups. So while configuring NAT, we don't want to make the NAT rule itself too complex, right? If we want to configure a NAT between a subnet and just one IP, so we just for ease of implementation, we have the concept of object groups. So what you can do is we can define an object group, and we can give it a name, and we can add the subnet in the object group, or we can add multiple subnets or multiple IP addresses in the object groups. For example, if you see the first example, protocol object group. So you can just see object group protocol TCP, and there we just added the entire TCP protocol as an object. So now when we create the rules, instead of saying TCP, this is a very simple example. We'll move on to complex examples. So let's actually move on to those. So network object group. So you can see object group, then the type of the group, which is network, and the name of the object, outside hosts, easily understandable name, outside hosts. And then we add the object there. Network object host 100.0.123, one host we added, and then another host we added, network object, and then so we added one host and one subnet, and we named this entire thing as outside hosts. So this is one object group. Now when we create the NAT rule, we can simply use outside hosts. We don't have to specify each and every IP address or each and every subnet that falls within that group. So any questions? I know this can be a little confusing. Okay. So different types of object groups are there. For example, ICMP type is there. Service object groups are also there. So again, service object groups is important because, so if you want to create rules for example, HTTP traffic, telnet traffic, multiple protocols at the same time. So what you do is you create a service object group and you add all those protocols in that object group. So you can simply use that in your rules and it will be implemented like that. So it's just to make your life easier. Okay, nested objects. So you can also create object groups that contain further object groups. So that is your concept of nested object groups. Any questions so far? Please feel free to ask. Is it clear what is an object group? What is an object? Okay, so we'll come back to NAT now. NAT can be used, a lot of scenarios are there, a lot of use cases are there for NAT. One of those use cases is one-to-many mapping. So if you see here, if for example, an external user wants to connect to an internal resource, all right? And using NAT, we have specified that one internal resource is mapped to 2 external IPs. So again, that user can connect to any of those 2 IPs and it will be able to access that resource. So you might have seen that implementation in your lives, right? Sometimes there are 2 IPs for the same thing. So that is an implementation of NAT. So NAT broadly has 2 types, static NAT and dynamic NAT. Are you already familiar with these concepts? Okay, I'm assuming not. So what is static NAT? Static NAT is you clearly define that this IP will be translated to that IP. 1-to-1 mapping. That is your static NAT. So if you can see here, you define 2 objects, object network R1, object network R2, and then you do NAT from London to Paris, source static, first object, second object. So your first IP is going to be translated to the second IP. Any questions? All right. So again, this is the same thing. Okay, so the next concept is static NAT port forwarding. So here what we want to do is that we are not just translating the IP address, we are also translating the port number. So an IP address, for example, in this example, anybody who is accessing this IP address at port 9999 will get translated to another IP address on port 23. So why is this useful? Any guesses on why we need this? For example, Telnet works on port 23, right? So only one port 23 is there. How will multiple users, how will multiple resources work on the same port? So sometimes we want to use different ports to access the same resource. So again, this is a port forwarding concept that we can use in NAT. Is this understandable? Clear? Any questions? Okay. Then let's talk about dynamic NAT. So static NAT was 1-to-1. Clearly define X is getting translated to Y, whether it's IP address, whether it's port number. Now when we talk about dynamic NAT, what we can do here is, we can translate a range of IP addresses to maybe 1 or 2 IPs. Or we can translate a range of IP addresses to just one interface. So it's one-to-many, it's unequal mapping basically. It's not clearly defined. So again, there are various subtypes of dynamic NAT as well. But in this example, you can see that the first object network range. So it is a range, but it's only 2 IPs, 10.0.123.50 and 51, only 2 IPs in the first range. And the second object is a subnet, 1.1.1.0 and /24, 255, 255, 255, 0. So this will have about 255 IP addresses. So now we are translating it dynamically. So NAT from London to Paris, dynamic range. So if we define it within the object, okay, let's not get into that. Let's look at the second rule only. So from London to Paris, source dynamic, first object, which is the entire subnet, is getting translated to the range, which is just 2 IPs, right? So when this happens, how is it handled? If more than 2 people are sending traffic, what will happen? We can't just translate it to 2 IPs, right? So in that case, NAT will automatically utilize port numbers to do that mapping. So dynamic NAT utilizes port numbers in most cases because it's not 1-to-1 mapping, right? It's not equal. So again, so the next concept is dynamic PAT, which is dynamic port address translation. It is also called interface overload. So here, instead of defining subnet, we use interface. We map an entire subnet, or we map a set of IPs to a firewall interface. For example, in this, let's see, there's a firewall. And on the inside of the firewall, you have an entire network. You have all you students, right? And on the outside, you have the internet. Now, all of you want to access the internet. So we can say NAT, all the IPs coming from the firewall to the outside interface. So the internet will see that all traffic is coming just from the outside interface. It will not see any of the internal IPs. So this is interface overload. And again, here also, ports will be utilized because it's just one interface, right? So ports will have to be utilized to accommodate all the requests coming in, all the translations that are happening. Any questions? Is the concept clear? Okay. So twice NAT. So this is another concept where we are not just translating the source. So a packet is coming, it has a source and it has a destination. So we can define a NAT rule that says, change the source address to this address. Now we'll add something more to the NAT rule to say that, the destination address also you change to some other address. So we are doing NAT 2 times on the source IP as well as the destination IP. So this concept is called twice NAT. There is no need to get into the syntax of it all because this is just a product specific syntax. It's more important to understand the concept. So you can say that, you are translating the source address, a real source address to a mapped source address and a mapped destination address to a real destination address. This might not be clear right now, but eventually it should be. So manual NAT breakdown, the twice NAT breakdown. So a packet is moving. If you see the rule breakdown, are you able to see this on your laptops as well? Okay, good. So NAT London to Paris. So we are going from the London interface to the Paris interface. This is the interface names. So NAT from London to Paris. Packets are moving from London to Paris interface. Source static. So we are defining a static NAT. Now we say the first object, the name of the first object is R1 real, right? That means it's the real IP address of the source that is initiating the traffic. And the next is R1 NAT, which means that to the external entity, you will see this R1 NAT object, the translated object, right? So source static, R1 real, R1 NAT. Now your regular NAT stops here. Now we are doing twice NAT. So then we will define destination static and then R2 NAT. So when a source is sending a packet, it will use a mapped IP address. It will think that it is talking to some other IP, but we will translate it to R2 real, which is the real destination IP on the internet. So again, the second translation will happen. And of course, you can translate the service also. So service TCP 1023 to TCP 23. So port also you can translate alongside it. So this is how a regular twice NAT rule looks like, where you're translating the source as well as the destination. This, is it clear though?
Why is the destination called
Okay. So what happens is that if you are inside a network, right, and you want to access some external resource. So what you do is that you are originating your traffic from your real IP address, okay? And you want to go to the destination, but you will not use the destination. So if you are applying NAT, we are using a firewall, you will use a mapped IP address to originate your packet. So you will think you are accessing 200.20.3.4, right? But the firewall or whatever device is there in between, it will translate it to the actual, for example, yahoo.com or some external website. So it will translate it to the real IP. So from your side, when you originate the packet, you will use your real IP and the mapped IP of the destination. That is how your source packet will look like. That is how the implementation happens. Now when it comes to the firewall, your real IP will be translated to the mapped IP and the mapped IP of the destination will be translated to the real IP of the destination. And that is how the packet will go out from the firewall. Then when it comes back, the reverse translation will happen. It is a little confusing to understand. I know if you ever get a chance to implement it, that is when you really see that why this is happening. But I mean, this is how the packet originates. Is that process clear? Okay. Anybody else? I know this is actually one of the most confusing NAT breakdowns, source and destination. If anybody wants me to repeat, please let me know. Okay, assuming it's clear. Okay, we have another concept called NAT exemption or identity NAT. So this is, again, let's observe the rules that are written here. So we have defined one object network, any subnet 00, which means your entire subnet. And we are defining a general NAT rule that says that, NAT from London to Paris dynamic interface. So we are using interface, dynamic PAT we are using. We are NATing it to the interface, right? So everything that is inside is being NATed to the interface. Now next what we are doing is we are defining two objects. Object network, one IP address, then the second object network R2, another IP address. And then we are configuring an exemption. So everything is NATed to that interface except, you can see the rule that is below, NAT London Paris source static, first object, second object. So whatever IP packets are coming, if you see the text in the red, right, everyone behind London is patted when they access anything in the Paris interface, except when R1 goes untranslated when it's accessing R2, which means when one IP on the inside, this one particular IP on the inside is accessing this one particular IP on the outside, NAT will not happen. So we are exempting it from NAT. And how are we doing it? We are saying source static and we are putting the same object. Real IP, NATed IP, we are using the same object. So it's getting translated to itself. That's how we are configuring it. So that's why it's called identity NAT. So there are two concepts at play here. If you don't want to translate something, or if you want to only partially, for example, you just want to translate the source and not the destination, or just the destination and not the source. So you can utilize identity NAT. Or if you want to configure an exemption, then also you can use identity NAT. Is this clear? The concept of exemption and the concept of identity NAT, translating something to itself. Okay. Next, we will talk about access control lists. So this is also a very basic concept that is used in firewalls in general. So what is an access control list? It is a rule. In short, it's a rule that allows or denies traffic based on certain parameters. That's the simplest way to put it. So there are two types of ACL, standard ACL and extended ACL. As the name suggests, standard is more basic, extended is more specific, but we will get into that. And on the ASA firewall or on Cisco devices, the access group command is used. So you can create multiple access lists and you can bind them to an interface using the access group commands. Again, I would say let's not get too much into the syntax part of it because that can vary, but the concept needs to be clear. So let's look at the general syntax of what an access list is. So access list is the keyword here. Then you define a name for the access list. Then you define whether this is an access list for permitting or for denying. So two keywords, deny or permit. And then you specify the protocol, source address, destination address, your 5-tuple, right? Source IP, destination IP, source port, destination port. Everybody is familiar with that, and protocol, TCP or IP. So you specify the 5-tuple, and that is how the access list will match the traffic to that tuple and it will perform the action, permit or deny. As simple as that. So again, by default, higher to lower traffic is allowed, right? So by default, traffic from lower to higher is not allowed, but access list, you can define an access list to go against this rule. That is what a firewall is all about, that it will deny everything until you specify that no, just allow this thing so that our network is secure. So as soon as you apply an ACL on an interface, the security level restriction will not apply. For that particular, for traffic matching that particular access list, the security level restriction will not apply. So again, two broad categories here, global ACLs. So you are not defining them on any interface level. So you are defining it globally for the entire firewall that, let's deny all ICMP traffic. It doesn't matter where it's coming from, where it's going, just deny all ICMP traffic. So something like that, we can apply a global ACL and do that. Okay, so one use case again is permitting inbound access. So if you see access list 100, permit, the action is permit, TCP, the protocol is TCP, any means everything. So from wherever the traffic is coming, if the destination is 171.11.23.2, this particular IP, then you permit it EQ80. EQ80 means on port 80. So any web traffic that is coming from anywhere outside to this particular IP, you permit. So that is a use case that is permitting inbound access. So that is your one use case. Then another use case is denying web access to the internet. So again, let's look at the access list. Access list name, deny, that is the action. Then TCP, the protocol is TCP. Any means from wherever it's coming, from wherever it's going. It doesn't matter. As long as it's port 80, as long as it's www, that's the protocol. As long as it's web traffic, we will deny all web traffic. And then the subsequent rules are going to be that we permit IP any. And so again, we can deny entire access to the internet using this particular ACL. So denies web traffic on port 80 from inside network to the internet. Nobody can access the internet from the inside, and all other traffic is permitted. So IP traffic and all is permitted. TCP, www, web traffic is denied. So talking about standard ACLs, I said two types of ACLs, right? Standard ACL and extended ACL. So standard ACL is simple source-based filtering and it has a limited functionality. And two examples are here given. Access list 10. 10 is the name of the access. Usually it's a numbered access list when we say standard ACL. Sorry, the action is permit, and then the first example, if you see, access list 10 permit host whatever the IP address is. So we are just saying that simple access list, just permit this particular host, and we'll apply it on an interface. So on that interface, any traffic that's coming from that particular host will be permitted. Okay. The second example is again the same thing. It's just instead of using the host keyword, we have used the IP range. So we say access list 10 permit, and then this 192.168.1.0, this entire IP range. So we're just allowing this IP range. It's a simple, so standard ACLs can be used for simple filtering, basic filtering scenarios, and usually they are used near the source to define the source. And for traffic restriction, permit or deny entire networks or just one particular IP. Simple use cases, that is your standard ACLs. Then we'll talk about extended ACLs. So contrary to standard ACLs, if we want to create more complex rules, more detailed, more granular control if we want over our network, we will use extended ACLs. So extended ACLs, we can specify source, destination, protocol, port, your entire 5-tuple you can specify. You can use it for cut-through proxy, NAT exemption, policy NAT. You can, for VPN connections, which again we will cover later. But a lot of use cases are there for extended ACLs. So here, let's look at the syntax of how we've used it. Access list, outside in. Outside in is the name of the access list. Extended is a keyword. Then the action is permit. Then protocol TCP. Then we define the host 1.1.1.1. Then the destination host 2.2.2.2. Then EQ23. So we specified the entire 5-tuple. So extended ACL, and then further, like I said, using access group command, we apply the ACL. So we say access group, outside in, which was the name, in, out. So whether we are applying it in direction or out direction. What this means is that is this access list applicable on traffic that is coming to the firewall or on traffic that is going out of the firewall. So that is the direction in which the access list is applied to the traffic. Interface outside. So on which interface? So on the outside interface, traffic that is going out of the firewall, let us apply this access list. So that is the concept. Any questions? Extended ACL. Is that ACL clear? Okay. So again, this is why we covered object groups. So instead of specifying the actual IPs, you can use object groups in the ACL. So you can see at the top, you've defined 3 object groups. One is a specific host and a subnet object group. Another is a service object groups. So then we can say access list, outside in, extended permit, TCP. Instead of saying host, we say object group. So your source will be the entire object group. And then the destination can also be another object group. And then for specifying the protocol also, you can use a service object group and say that, for this list of protocols, for this list of IPs, going to another list of IPs, you permit all the traffic or you deny all the traffic. So for complex scenarios, we can use object groups in the access control lists. So far, so good? All right. So again, if we apply a lot of ACLs on a firewall, if we are not conscious about the way for everything we need, we are blindly applying ACLs, For large organizations especially, this happens that the ACL count can reach a very high number. It can go up until thousands or 10,000s or lakhs. And then when that happens, every time a packet is coming, the firewall needs to look at so many ACLs to realize that, this is the one it's matching, whether to permit or deny. So when something like that happens, it can cause issues. It can deteriorate the processing of the firewall. It can lower the speed. A lot of things can happen. So it can affect session establishment. It can affect the throughput of the firewall. So we should not do that. We should be conscious about how we are using ACLs, and we should always try to optimize the way that we are implementing ACLs. So conscious practices we should follow while we are implementing ACLs in a firewall. That's the entire point of that. So, yes, that is very much possible. So if it's like 10,000 rules and some new engineer, some new administrator is coming, he is not going to go through those 10,000 rules before creating a new rule. So sometimes that contradiction also can happen. So this is why we say that, such a large rule count should not be there. We should always try to, that's why object and object groups also come into picture. So if our structure is simple, it's easy to understand what is being denied, what is being permitted. So if someone new, some new network administrator is also coming, they will also have a better visibility of, whether a new rule might contradict. And in case how it's processed, so again, the most specific rule is processed first. So that's how the access, so we'll get into that also actually. The order in which the rules are processed, we'll talk about that also.
So one thing is, in Cisco devices, NATs and ACLs are top to bottom. So if you have conflicting rules at the top, multiple rules can hit, and an ambiguous action can take place. So if one is a contradictory of the other, both of the rules will hit, and we don't know what will be the result. So there are certain checks you as an administrator can take. You can create scripts to see if there is a ACL conflict, if there is a NAT conflict happening. But if a rule match happens, the topmost rule will always hit. So it will not look at any other rules at the bottom. So always when we are talking about ACLs, specific rules at the top, and supernet rules or broader rules at the bottom, right? So that is one thing. You can do it in the background, but in operation, always if a rule is hit, no other checks at the bottom of the rule.
But in case, if there are two rules, one is less specific, one is more specific. So whatever traffic is coming, it's the more specific rule is going to be hit. Right. Okay, 1 second. Okay, so we talked about the firewall. What is the firewall doing? Permitting or denying traffic. Access control lists it's using based on 5 tuples, right? And it's doing NAT also. It's doing the network address translations, and it is protecting your inside network from the outside network. So next up, we come to the concept of AAA. Are you familiar with the concept of AAA? Okay, then we have a quick question just for fun, I would say. So please go to the Slido poll again. Same Slido poll. And we just want to ask you what you think is AAA. Huh? Yeah.
It will present on.
No, it won't present on this. It will just open a new tab. That's all. Okay, we have 25 inputs. How many people are here? I think at least 40 people are here, right? We'll give 10 seconds more for your inputs. We have 27 answers now. Okay. No, they can see. You guys can see the results, right? Okay, perfect. All right. So AAA stands for, the correct answer is, what is the highest voted one? Authentication, authorization, and accounting. So to the people who voted for advanced antivirus application, that is incorrect. In terms of network security, whenever we talk about, AAA is authentication, authorization, and accounting. Am I still audible at the back? Please let me know if at any point I stop being audible, okay? All right. So let's talk about AAA. So before I get into this, I'll go back to this first. So we have a firewall here, and you guys are guests in VIT, coming back to the same scenario, right? And you are accessing some of the VIT internal resources. You are accessing the internet. Now, what if there is an imposter among all of you? What if that person comes and connects to the Wi-Fi? What is stopping him? What is it that you guys have that that imposter is not going to have? Credentials, absolutely. So a username and a password that, you know, your organizers might have given you to access the internet, right? So those credentials, when you are supplying, where are you supplying those credentials? Is the firewall checking those credentials? Firewall is just checking 5 tuple, right? It's checking source IP, destination IP, and all that. So how are your credentials getting validated? Any answers? On the server side. Server side where? Here? So there is, so it's a server that contains usernames and passwords, right? So yeah, so broadly, yes, that is the concept. So we have an AD, Active Directory, or we can have any LDAP directory or something. So AD is a database of usernames and passwords, in a very layman term, of usernames and passwords. And we have something called as a AAA server. And the entire task of this server is to receive requests and to yes, to determine whether the supplied credentials are correct or not. If they are correct, it will accept the connection. Otherwise, it will deny the connection. So along the firewall, alongside of the firewall, another security device that we have is the AAA server. AAA server is connected to the AD. Now, AAA server in itself is also capable of handling usernames and passwords, but for large organizations, if an organization, for example, has some 40-50,000 employees or students in this case, so then it needs an external server to manage the credentials and the AAA server to perform actions of authentication, authorization, of doing the checks and everything. So this is the AAA server. So if you look at the slide, without a AAA server, you have poor context awareness. You know that some IP address is trying to access some resource. Apart from that, you know nothing. You just know the IP address. You don't know who that person is. You don't know whether that person is a legitimate person or it's an imposter, it's an attacker. But if you have a rich context awareness, utilizing something like a AAA server, you will know that, okay, it's Bob, the employee, who's trying to access this particular this resource. And Bob has an Apple iPad, or he has a Mac OS or a Windows laptop. And at this particular timestamp, he tried to log in. He supplied his credentials. He connected via Wi-Fi and not via Ethernet. So what was the location with which he logged in? What is the CPU serial number of his device? So in corporates, in organizations, you know, companies give you company laptops, right? So you can only access the network through those devices because they are security compliant. So what is the serial number of the device? What is the CPU, memory? Are there any issues? What are the processes running? So with a AAA server, you can have very rich context awareness of who is accessing your network, how they are accessing, when they are accessing. All these questions can be answered if you use the concept of AAA. So what is AAA? Authentication. Who are you? What is your identity? So I am an intern and my password proves it. So your credential proves your identity. Second is authorization. So if you are a student, you can access maybe the examination portal and the results portal. If you are a faculty, you can access some other internal resources, some course structures and some, again, another part of the examination portal. So what is your role? So that is authorization. So what can you do in the network? Once you've logged into the network, what is your privilege level? So I am user intern can access host server A using SSH. So you are defining a rule that this particular user, if it falls in this category, intern category, then he can only access these resources. So that is the concept of authorization. The third is accounting. What did you do? What time did you log in? How much time were you logged in? What was the entire duration of your activity? And how many times did you try to log in? Why is how many times important? Can anyone tell me? If an intern A is accessing the server 100 times in 5 minutes, yes, it could be a brute force attack, it could be a denial of service attack, it can be a malicious activity, because obviously a legitimate user cannot access something 100 times in 5 minutes. It has to be a continuous session. So accounting is basically keeping a track of everything that is happening. So AAA, authentication, authorization and accounting. So this is the same thing. So you can have different types of devices, printers, laptops, tablets, phones. So the first step is authentication. What is the endpoint? Who does it belong to? Identifying who you are. And then you add the context to it. That if it's an intern, if it's a senior employee, if it's a manager, then what does the endpoint has an access to? So again, in this scenario, as guest users in VIT, you will have limited access. You cannot access any of the student portals, faculty portals, nothing. So that is your authorization level. So let's talk about AAA protocols. So AAA, the most commonly used protocol in AAA is Radius. So broadly speaking, Radius is a client-server protocol. Actually, is it time to take a break? All right. We can take some. Okay. Okay. So Radius is a client-server protocol. So what happens is, client-server protocol. So there needs to be a client and there needs to be a server. What is the server? It's the AAA server, right? What is the client? When we talk about Radius, what is the client? It's not you, it's not the end user. It's the intermediate device, whatever is connected to the AAA. So in this case, if you see, if you are connected to a switch or a WLC or an access point, then that will act as a Radius client and it will communicate with the AAA server. So that is where the Radius protocol will come into picture. So this switch or this access point will take your credentials and it will communicate with the AAA server and it will determine what access you need, whether you are a valid user, what access you are given, and then it will give that access to you. So very broadly speaking, that's how Radius works, but we will get into the specifics of this also. So Radius stands for Remote Authentication Dial-in User Service. Again, fancy name for a very normal protocol. So Radius combines authentication and authorization in one phase only. And the port numbers for Radius, you can see UDP port 1812.1615. And for accounting, UDP port 1813 and 1646 will be used. And the username field is not encrypted. We will see that. We'll have a short demo where we'll see that. And the password field is encrypted. And Radius is mainly used for network access. For device administration, usually another protocol is used, but we can use Radius also. It's not recommended though. Can anybody tell me, what do you think is the difference between network access and device administration? They're two different concepts. You can guess, I don't expect you to know. You can guess. All right, so network access is when a user like you is trying to access the network. Very simple, straightforward. Device administration is that an organization has the network devices, right? Switches, routers, access point. So administering those devices, the network administrator wants to manage those devices, wants to configure those devices, wants to assign different accesses to those devices itself. So that is device administration. So network access is pertaining to endpoints and device administration is pertaining to network devices. That is the only difference between the two. The AAA actions apply to both of these categories. So what happens? User initiates an authentication request to the network access server. Network access server, in a simple term, let's say it's a switch. So user initiates an authentication. It says that, I want to log into the network. Then the switch prompts for username and password, depending on which protocol is used. So we have two protocols here, PAP and CHAP, password authentication protocol and challenge handshake authentication protocol. Again, we'll not get into that, but the switch will ask the user that, okay, you want to access the network, give me the username and password. So the user will reply with their credentials. Then what will happen is that the switch, which is the Radius client now, it will send the username and the encrypted password to the AAA server, or the Radius server in this case we'll call it. Then the Radius server will validate those credentials and it will reply with accept, reject or challenge. And then the Radius client will act, so it will give you the required access based on the response it got from the server. If it got accept, then it will grant you the access. If it got reject, it will deny you the access. So final action the client will take, and either you will log into the network or you will not log into the network. It's as simple as that. So there are certain Radius packet types. So for authentication and authorization, we have access request. Again, this is all self-explanatory, but you can go ahead and read it. Access request, access challenge, access accept, and access reject. For accounting, we have an accounting request packet and accounting response packet. Accounting is again just logging the activity that is happening, right? So that is the accounting packet. Another interesting packet is the change of authorization. So what happens if a user sends a request and says, I want to log into the network, and then the AAA server challenges them. It says that, your system is not meeting my requirements, so I cannot grant you access. So you fulfill the requirements first. I am giving you partial access. You fulfill those requirements first and then I will give you full access. So what the user does is, the user, for example, some software is missing or some update is missing. The user performs the update and then the Radius server will send a change of authorization. It will detect that, okay, this requirement is satisfied now. So now I will send a change of authorization and grant you full access. So a COA packet is another Radius packet that is used in specific scenarios. Are the packet types understandable, clear? We'll go through a small example also for that. Okay, so this is the packet flow. So again, this is the same thing that I repeated before, that user is initiating a connection, it's communicating with the switch. Then the switch is actually creating those Radius packets and communicating with the AAA server. Then the server is replying. So again, there are two types of flows here, authentication authorization flow and accounting flow. I will give you a minute or so to just go through this. If there are any questions, please let me know. All right, any questions so far? Any other questions? Okay, so we will do a quick activity. So have you guys received access to a box folder from Cisco? There is a box folder, right? Okay, so there is a file called radius_localhost.pcapng. So please download that file and open it using Wireshark.
Everyone has Wireshark installed?
Okay. Okay, so it'll open something like this. Just give me a thumbs up if you are able to open the file in Wireshark. Okay. Anybody who's not able to open? Zoom chat we've shared that. Oh, okay, we'll share it again. I'm clicking the wrong buttons. So I've added it again. You can. So if you've opened the PCAP file in Wireshark, just try to explore the packets. It's a radius connection. You can see the radius packets. How can I minimize this? Minimize. Okay. So if you see the info section, you can see the type of packet that's there. Access request, access challenge, access accept. So packet number 8, packet number 9. If you open packet number 9 and go to the radius protocol at the bottom. So click on packet number 9 and at the bottom you see a radius protocol tab, right? Just expand that and then further expand the attribute value pairs. So there you can see the username is Steve, the value is Steve, and then the password is encrypted. And then we can see the IP address also from where the packet is originating and port numbers and everything we can see. And then when you go to the next packet, which is packet number 10, you will see that it says this is a response to a request in frame 9. So the access request came in and since the password was correct, the access accept packet was returned. Yeah. Has everybody seen packet number 9? Username is Steve, password is encrypted. And then packet number 10. Anybody who's not, please let me know anybody who's not done that because we won't go ahead further if we are not done exploring. Yeah. Yeah? Yeah, correct. No, not this one, Go back. The PCAP. Radius. Yeah, this one. Yeah, just download. Is there anybody who's stuck anywhere? Please raise your hands, we'll just help you out. Okay. So if you observe packet number 15, 16 and 17, so one access request went, there was no response, so it kept sending access requests. That's why we say it's a connection-less protocol. There's no SYN, ACK, SYN like in TCP, right? That's not happening. It'll keep sending requests until it receives a response. Request ID. So in packet 15, you can see that the access request ID is 184. But since there was no response, with the same access request ID, it's keeping on sending requests until it received an access accept. So duplicate request is also marked over there. So either accept, reject, or timeout, something will happen. Until that, it will keep sending the request with the same ID. So that's an overview of the radius traffic flow. Are you able to access? Able to follow? Okay. Packet 9 and 10 you saw? Okay. Anybody else stuck anywhere? Okay. Let's go back. Okay. So next up we talk about device administration. So this is another thing that I talked about, right? Network access versus device administration. So device administration is actually managing the switches and routers and your network devices that are there. So how do you access these devices? What if you want to access a router or a switch? You use Telnet or SSH. You don't have a GUI like in Windows or Mac or Linux. That's not how you do, right? You access it via their terminal. So that is why you use the Telnet or SSH or serial connection. So 3 ways you can access, and then you can configure these devices or you can make changes to these devices. So another protocol that we have here is the Terminal Access Controller Access Control System. Again, a very fancy name. We call it TACACS. It's the counterpart of Radius for device administration. So it is a AAA standard protocol for controlling access to the Unix terminals. And Cisco has created TACACS Plus, which is Cisco proprietary, but it's an enhancement to TACACS only. So that TACACS is basically the protocol. We have the traffic flow for TACACS also. So it does authentication, authorization, shell authorization. So you can log into a device, but can you access the edit mode of the device? Like, can you actually make changes or can you just view the device? So whether you can access the shell of the device, whether you have access to run specific commands or not. So commands have privilege levels. For anybody who's familiar with the Linux operating system, right? Commands have privilege levels. There are certain commands you can only run if you're a super user, right? You do sudo su and then you run a command. So different functionalities the TACACS protocol can provide in terms of authentication and authorization. So again, this is the traffic flow for TACACS. We don't have a demo for this, but you can have a look at it. So once you are authorized, you can have multiple levels of, once you are authenticated, you can have multiple levels of authorization.